All right, this next video is the video you've all been waiting for, or maybe all been dreading. We're going to start with the most important thing. Studies have shown that if you physically smile, even if you're not happy, your body will feel a little happier. I'm pretty sure I've seen that in a study. If that's false, let me know. I'm pretty sure I've read that. So we'll just start, maybe get a little smile out of the way, because this video is going to be tough. All right. And so remember, when we're verifying identities, it's just like what I mentioned in an earlier video in this section, is that there's no answer. The answer is the whole proof. The answer is the entire process. So how you write your work is important. And everything that we covered in 9.1 for verifying identities is also going to hold true for this section in 9.2 as well. We just have new tools, namely co-function identities and these sum and difference formulas. So remember what we're going to do, just like in 9.1, we're going to start with the messier side. We're going to write things in terms of sines and cosines. We're going to keep track of where we're trying to get to. And we're going to use, hopefully, a lot of identities. So without further ado, example 8. Verify the following identities. Part A. I want you to verify that the sine of alpha plus beta plus the sine of alpha minus beta is equal to 2 times the sine of alpha times the cosine of beta. So we just start with one of these and try to show that it's equal to the other side. And we can't do it like this, right? We can't just keep writing equals here and keep working with this and keep having this on the side, because that's starting with what we're trying to prove. If you start with what you're trying to prove, then it's an invalid proof, essentially. It's basically, I can't think of a good way of explaining this, but if it's like if someone asks you to prove that the sky is yellow and you say, well, let's start by assuming that the sky is yellow. Well, then it's yellow. Of course it's yellow. And that's a terrible explanation, but we have to start with one side and not write the other side until we get it. All right, don't start with what you're trying to prove. So we'll start with the messier side. In this case, it's going to be the left side. There's more we can do with the left side. Specifically, the left side has alphas plus betas. And we know what we can do with that. We know what the sine of alpha plus beta is. That's a formula. It's going to be the sine of the first, cosine of the second, plus the cosine of the first times the sine of the second. So that's just this part. Now we do the other formula for the second part. That's going to be, again, sine of the first angle, cosine of the first angle, minus the cosine of the first angle. I'm saying it wrong, but I'm writing it right. Sorry. Sine of the second angle. That's the second part. Now we just try to simplify, hope things work out, keeping in mind where we're trying to get to. Let's look at these. Let's look at this first term. Sine alpha cosine beta. Oh, we also have a sine alpha cosine beta here. Let's combine like terms. Now we have two of them. We had one sine alpha cosine beta. We added it to another sine alpha cosine beta. Now we have two of them. And we have a cosine alpha sine beta and a minus a cosine alpha sine beta. Oh, great. Those two cancel. We started with the left-hand side, LHS, left-hand side. We simplified, and lo and behold, we showed that it equals the right-hand side. We're done. Just as easy as that. They're not always going to be as easy as that, but that's the process. We have another one in the selected homework problems video. Let's do another problem. Sine of alpha minus beta divided by cosine alpha cosine beta equals the tangent of alpha minus the tangent of beta. Now don't get beta-ed. Sorry, don't get baited here. The right-hand side is not, we can't use the angle difference formula for the right-hand side. That's the tangent of alpha minus beta, not the tangent of alpha minus the tangent of beta. There's not much we can do with the right-hand side. There is some stuff that we can do, honestly. And actually, even though I'm saying this right now, I do see how we could approach the right-hand side. We would write it in sines and cosines. We'd get a common denominator. These are very standard things that we'll do, that we did in 9.1 as well. Write in sines and cosines, get a common denominator, and then you're going to actually see something happen. And if you're curious, I would pause the video right now and try to do that. But if we start with the messier side, we'd start with the left-hand side. But you can also start with the right-hand side. On all of these, just some of them are harder if you start with the easier side. So what's the sine of alpha minus beta? Use the formula again. Sine alpha cosine beta minus cosine alpha sine beta over the denominator. And we've basically done all the tools that we have. Start with the messier side. Use identities or formulas if we can. Write things in sines and cosines. We have all of this. The other main thing is to look at where we're going. Where we're going is something minus something else. And if you wanted to, you could go off to the right and say that we have the sine of alpha over the cosine of alpha minus the sine of beta over the cosine of beta. So if you want to work both sides at the same time, this is how you need to do it. You can't connect these with an equal sign because that's what we're trying to prove. We don't know that. But if you did want to work in tandem and rewrite both sides at once, you could. So another strategy, another thing to think about and look for here, even if you didn't do the green thing, even if you did not do the green thing, you could say, well, I have a fraction here, a single fraction, but look at where I'm trying to get to should have just something minus something else. So we need to split up this fraction. So splitting up fractions is easy when there's addition or subtraction in the numerator. It's much worse when there's addition and subtraction in the denominator. So again, it's going to be the first part divided by the denominator minus the second part divided by that same denominator. And then we hope that things happen. Well, cosine of beta divided by the cosine of beta, cosine alpha divided by the cosine of alpha, what are we left with? Sine alpha over cosine alpha minus sine beta over cosine beta. Great. So if you wrote the green thing, then you could say that this equals the right-hand side. If you didn't write the green thing, you'd have to do one more step. Because again, you have to really show why this is the case. And then we could say, yep, that's the right-hand side. Check. Proofed. I should not make that a thing. We'll do another one of these in the next video if you want more practice. Otherwise, good luck. Let me know if you have questions. And enjoy my gift of mathematics to you. I never know how to end these videos. That's a good one.